So where do we begin? Now, the TBO project was just the beginning. It was one of the many platforms we developed at Eurocaps. There was an espresso aluminium capsules, fiber-based capsules, and a few proprietary systems I still can't talk about. These are ongoing and confidential. So the next part of this series is going to dig into something that most people completely take for granted. Just how complex the single-serve coffee business actually is. People look at a capsule and think, it's just coffee in a little cup. How hard can it be? Right? Okay, well, let's start with just one example, the Espresso aluminium capsule. The capsule looks simple. It's anything but. First, the aluminium. Everyone assumes that it's just aluminum. There are hundreds of grades of aluminium, different strengths, different tempers, different forming properties. So step one, you have to choose the alloy. Then choose the thickness. Too thick, it won't form properly. Too thin, you get tears and holes. This is called foul pli. And these capsules are manufactured with deep drawing, meaning a flat disc is stamped into a deep cup shape in one stroke, and on the return stroke, the machine forms the roll rim. Now, an espresso capsule has a depth to diameter ratio of almost 1:1. From a forming standpoint, that's basically nightmare fuel. The inner lacquer inside the capsule is also a food-safe lacquer. It has two very specific jobs. One is to prevent the coffee from touching the bare aluminium, and two, ensure that the capsule surface is chemically compatible with the lid sealing lacquer, because the lid in the capsule must bond perfectly. And if that bond fails, the coffee will oxidize and be stale. Now let's talk about consumer sustainability pressure. Consumers, rightly, are now asking for recycled aluminium. So now we're working with can stock, generally 3000 series alloys. Great for recycling, terrible for forming, and recycled alloys are typically harder, less ductile, and less forgiving, which means that you now need new forming tools, new clearances, new annealing curves, new breakage rates, new quality systems, and a lot of expensive trial and error. A small change on paper is a multi-million euro engineering challenge in real life. Then let's talk about the silicon lubricant. Here's a detail that nobody outside the industry knows. The silicon lubricant on the capsule is not optional. It's needed in the forming process itself, so the aluminium can slide across the tooling during deep drawing process. And it's got to do that without tearing, without wrinkling, and without sticking to the dies. It also helps the finished capsule feed smoothly through the filling and sealing machines and to the consumer's Espresso machine. But silicone is very slippery, which now creates another headache. On the back of the capsule, of the gasket, we have a gasket, and this must stick to that same surface. So now we are balancing how much silicone is applied, the surface energy of the aluminium, the chemistry of the gasket adhesive, the cure schedule, and the heat profile during the application. Apply too much silicone, the gasket won't stick. Apply too little, the capsule cracks during forming. There's no margin here. It's a tightrope. So now let's talk about the famous gasket, the little ring under the capsule flange. It's absolutely mission critical. Yeah. There's decisions include thickness, the number of layers, whether it absorbs water or repels it, whether there's printing on it or no print, the ink chemistry, and whether that ink is stable under 19 bars of hot water, and how the gasket is attached. Is it heat sealed, adhesive, and pressure bond, and whether that process damages the lacquer needed for the lid sealing. Every choice affects the crema, extraction rate, machine compatibility, and whether the capsule behaves as it should when brewed. Now let's talk about the lid. The lid comes in different aluminium thicknesses, 20 micron, 30 micron, 40 micron, 50 micron. And then when we decide on embossing, which directly changes how the water flows through the lid during brewing, how the pressure builds, how the lid ruptures against the pyramid plate, and the extraction curve. full embossed, silk embossed, worm embossed, spot embossed, or just a logo, they all brew differently. This is not just a decoration, it's fluid dynamics. And then there are the patents. As if material science, forming physics, and sealing chemistry weren't enough, we also have to design around patents. And not just a few. The single serve industry is one of the most heavily patented consumer ecosystems in the world. Nestle, of course, has layers of core patents, but then you've got machine manufacturers, competing capsule companies, material suppliers, barrier film suppliers, barrier film developers, even tooling and process patents. Everyone is filing IP as both offense and defense. So every decision we've talked about so far, alloy, the lacquer system, the flange, the gasket, the lid embossing, all of it has to be vetted. Is it already patented? Has it expired? Is it expiring soon? Is it enforceable? Can we design around it? Are we infringing unknowingly? And here's the fun part. Patents don't just describe what works. They often describe what doesn't work too. So sometimes the only viable pathway is to invent something new, not because it's better on day one, but because it's the only legal way to exist in the market at all. This is why capsule development is never just engineering. It's engineering plus legal strategy, plus timing, and plus a competitive intelligence. You are constantly navigating a moving maze while building the maze around you. And we still haven't touched the coffee yet. The full weight alone is a balancing act. More coffee equals stronger taste, but slower flow. Less coffee is faster flow, but a weaker taste. Then the roast profile affects the grind. The grind affects the flow. The flow affects the crema. Crema affects perceived flavor. And then we have degassing. Freshly roasted coffee releases CO2 for days. Too much gas trapped, the capsule, you run the risk of the lid coming loose and then the coffee goes stale. Too little gas, the coffee tastes flat and the crema is weak. And decaf behaves like a different material entirely. It can sometimes brew as much as 2 times longer if you're not careful. So where do we begin? Right here. Over the next few episodes, we'll break down each part: the materials, forming, sealing, brewing, roasting, grinding, and show how all these small engineering decisions are what makes that 30-second espresso actually work. Because the capsule isn't simple. It's precision engineering, chemistry, fluid mechanics, and coffee artistry compressed into 5 or 5.5 grams of magic. So thanks for watching, and until next week, if you enjoyed this, please like and subscribe, and we'll keep it going. Thank you.